Okay, today's topic is going to be solving exponential and logarithmic equations. I believe I have about 12 or 13 examples, but the first thing that I'm going to cover is the last thing that I covered last workshop last week, which is writing. This is like a quick review of writing logarithmic equations into exponential equations and writing exponential equations into logarithmic equations. This is from last week. I'm going to do like 3 slides from here. And then I'm going to begin solving, okay, because all these go together, logarithmic and exponential equations. Okay, so to begin, this is like a quick review from last week, writing exponential equations into logarithmic equations and vice versa. So a definition of logarithms to the base a. Y equals to log base a x means a to the y equals x. Okay, example 1, write each logarithmic equation into an exponential equation. So this is my logarithmic equation. So I want to know what the a is, what my x is, and what my y is. So if you notice, then I have to put it into exponential. Okay, so if you notice, my a is 9, my x is 81, and my y is 2. So then you go back to the exponential form, and it's going to be 9 squared equals 81 because my a was 9, my y is 2, and my x is 81. Now, example number 2, I'm going to go the other way. It's going to be from exponential equation into a logarithmic equation. And like I said earlier, this is only like a quick review of what I covered last week. So we have 5 to the third power equals to 125. This is an exponential form. So to put it in the logarithmic form, we transform the exponential form into logarithmic form, which is a to the y equals x, means y equals to log base a x. So my a is 5, my y is 3, and my x is 125. So there's my y, right? My y is 3, my a is 5, the base, and my x is 125. But at times, the answer in the back of the book has it the other way, which is log a base 5, 125 equals 3. So these two are the same thing. Okay. Now, I'm going to do a quick graph of each one, and then we start with solving exponential and logarithmic equations. So in order to graph without a calculator, must convert logarithmic equations to an exponential equation. Okay, but first, let's review what are exponential functions. These are exponential functions. Why? Because the exponent is a variable. Okay, and recall from last week, a to the mn, right, is the same thing as a to the x. This is also exponential. A is a base. The exponent is a variable or the letter, right? At times, the students, they don't know the vocabulary. So please make sure that you call the letters in math, call them variables, okay? And the letter is frequently x. So f of x equals a to the x. And a has to be more than 0. So to graph it, okay, we're going to plug in values. And like I mentioned last time, that the most common values used for exponential and for logarithmic graphing equations or functions, you use -2, -1, 0, 1, 2, and 3. These are the most common points to use. Okay, this is my x, this is my y. So let's put the values for the x, right? So let's put all these values here. So when x is -2, right? Let's go back here to the function, right? The function. So I'm going to plug in -2 for every x. So f of -2 means 2 to the -2nd power. And these were from the rules from last week, the negative rule, which you make it positive by sending the 2 and the positive exponent to the denominator. Is equal to 1/4. And same thing with -1, right? So we plug in -1 for the x, and it gives us 1/2 to the first power, which is equal to 1/2. When we use 0, we're going to get evaluate f of 0, which 2 to the 0 power is always 1. Anything to the 0 power is 1. So when x is 0, y is 1. Now let's use 1. Now let's evaluate f of 1, which means 2 to the first power because I'm plugging in all these numbers to where the x is as the exponent, and the function is equal to 2. So when x is 2, we're going to evaluate f of 2, which is equal to 4. So when x is 2, y is 4. And finally, when x is 3, we're going to evaluate f of 3, which is 2 to the third power equals 8. Why? Because 2 times 2 times 2 is equal to 8. So then, guys, this is my graph. Okay, and again, how do we graph it? When x is negative, right? These are my x values on the coordinate plane, and these are my y's. So when x is negative 2, y is 1/4. 1/4 means that you're going to cut the first unit. This is 0, this is 1. You're going to cut it into 4 equal parts. So 4 equal parts will be about right. There's 1/4, 2/4, 3/4, and 4/4. So 1/4 will be about right there. And when x is negative 1, it's going to be about 1/2. When x is 0, it's going to be 1. When x is 1, it's going to be about 2. When x is 2, it's going to be 4. And when x is 3, it's going to be like 8. All the way right there. And that's how you match the graph. Okay. Now let's graph the logarithmic functions. Here's when, in order to graph without a calculator, must convert logarithmic equation to an exponential equation. So here we go. We have y equals to log of base ax. It's going to be a to the y equals x. So y equals to log of base 2 of x. This becomes, right, my a is my 2, my y stays a y, and the x stays as x. So 2 to the y equals x. But here, instead of plugging in values for the x, we're going to plug them in for y's. Because if we plug them in for x, it's going to be kind of difficult to solve for y. It can still be done, but it's going to be a tedious process. So that's why we plug in the values for y as the exponent. And again, this is similar to what we did last time, right? So when we plug in negative 2 here, guys, right, it's going to be 1/4. And I did this on the previous slide. But instead of plugging in for the y here, it was the x because it was 2 to the x equals y. But anyway, we get these are my x values that we get when we plug in these values for y. So to graph this graph, this is a graph of the logarithmic function, and this is the one that we graphed on the previous slide. And how do we graph the log function? When x is 1/4, right? So we divide this little unit here in fourth. This is 1/2, so 1/4 must be about right there. So we go all the way down to negative 2. And when it's 1/2, it's going to be 1. I mean negative 1. And when it's 1, it's going to be 0, right? And then it's 2, it's going to be 1. When it's 4, it's going to be 2. And when x is 8, it's going to be 3. So that's my graph. And these two are inverse of each other, which that's another topic that's going to be discussed later on. Okay. So this is my my exponential function, right? And this is my logarithmic function. Okay, now here we go, guys. This is the main topic for today's workshop. Solving exponential equations. To solve exponential equations without a calculator, you need to know previous topics such as, this is previous topics from before. You have to know perfect squares. At least know all the way to 10. Like 2 squared equals 4, 3 squared equals 9, right? And so forth all the way to 10. The more that you know, the better off you'll be. You have to know perfect cubes. The perfect cubes know at least all the way to 6. Like 2 cubes. I mean, why didn't I put 1 there? Because 1 to the third power is equal to 1. These are the main ones. I didn't put 1 there because 1 to any power will be 1. So anyway, we have to know 2 to the third power is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and 6 cubed is 216. Only the squares and the cubes have 2 names. For example, this can be called 2 square or 2 to the second power. This can be called 2 cube or 2 to the third power. After that, they're all called 2 to whatever power that we're going to. For example, these are my fourth roots. This is called 2 to the fourth power, 3 to the fourth power, and so forth. But 2 to the fourth power is 16, 3 to the fourth power is 81, 4 to the fourth power is 256, and 5 to the fourth power is 625. You have to know at least these right here. Okay, at least the perfect squares all the way to the perfect fourth roots, or to the fourth roots. Now, exponential expressions, you have to know that A is called the base and M is the exponent. Okay, all these are crucial, guys, for what we're going to be doing solving exponential equations and logarithmic equations. And also, you have to know the exponent power rule. A power raised to a power, you multiply the powers. Okay, this is something that they have to know for this section here. And also, you have to know how to solve one variable equations. An example of a one variable equation can be something like 2x plus 8 equals 14. You have to know how to solve those two. Okay, so all this information you need to know to move on. Okay, now, this is a rule for solving. This rule here means when you have, let A be a positive real number, with A cannot be 1. Because if A is 1, 1 to any power will be the same thing, will be 1. That's why A cannot be 1. But anyway, if A to the U equals A to the V, then U must equal V. In order to apply this rule, you have to have the same base, right? These are the same bases. You see, if these are not the same, you cannot apply the rule. So example number 5, right? We have the same base, correct? So same base, we apply the rule. So if the bases are the same, which are 3, then the exponents must equal to each other. So x equals to 5. Okay? This is example number 6. You have a to the x equals 2 to the 5th. Here, we cannot apply the rule yet. Why? Because the bases are not the same. So then here is we have to know that the 2 cubed, right, that x equals to 2 cubed. You see, because I want to match the bases to apply the rule. So then, my 8 is the same thing as 2 cubed. Right? And then we bring down the exponent. So now still, right? So then we apply the power rule. Remember, the power rule means a base raised to a power to another power, we multiply the powers. Apply the exponent power rule. Right? So it's going to be 2 to the 3x equals 2 to the 5th power. Now we have the same base. Now we can apply the rule. So when you have the same base, right, like a to the u equals a to the v, then the exponent must equal to each other. So then 3x equals to 5. And now we solve the basic one variable equation. We divide both sides by 3. So x equals to 5 over 3. Okay, now, the best thing about all these, when you're solving, that you can always check your work. Okay, so how can we check our work? We go back to the original problem here, right? Example number 6. I'm going to plug in 5/3 for x. X equals to 5/3, right? That was my solution. So there's my 8 raised to the 5/3 power equals 2 to the 5th. So now here, you can plug into the calculator. But be real careful when you plug it in there, because some calculators does not give you the exponent. You have to put like a little caret, like like a pointer like that, right, on your calculator, and then you have to put it in parentheses. But if it gives you the exponent there in the calculator, then you put 5 divided by 3. And you can also solve it without a calculator. Okay? So a to the 5/3 power equals 32. So 32 equals 32, so it checks out. Okay, now here's how you do it without a calculator. Okay, because you have to know it. You have to know how to use a calculator, of course, and also you have to know how to do it without a calculator. So I'm going to use the fractional exponent rule. Right, this is a to the 5/3. Right, so it's the same thing as a to the mn. If you notice, a is called the radicand. The 3, right, this the end here is called my index. right? So my a goes inside the radical sign, which this is called my radicand. My fraction 5/3, right? Like m over n. My m is my exponent for the a here, and my n is called my index. So then, what's the cube root of 8? The cube root of 8 is 2. 2 to the 5th power equals 32. This is crucial, guys, when you get to upper level math courses, because when you get to 1325, you have to know that when you do a 1325. Okay. Okay, let's continue with solving exponential equations. We have example number 7. We have 9 to the x equals 27. Here, right, these are not the same base. So then we know that 9 to the something power does not give me 27, right? Gives me 81. So here, guys, we have to use different bases for both of them. So we have to know what bases they have in common. You see, find the common basis between 9 and 27. And if you know your perfect squares and perfect cubes, right, we should know that 9 equals to 3 squared. And we know that 27 equals to 3 cubed, right? From the previous, I think it was slide number 3, that I told you that it was crucial to know all these right here. Here's where they come into play. So now I'm going to replace a 9 with 3 squared, right? And bring down the x. I'm going to replace the 27 with 3 cubed. Then these are not the same yet, right? They're not the same because they have to be just by themselves, the bases. So then we apply the power rule, the exponential power rule. When you have a power, the base raised to the power to another power, we multiply the powers. Right, so it's going to be 3 to the 2x, and it's going to just be 3 to the 3rd power. Now we have the same basis, which is a 3. Now we can apply the rule. Okay? So again, when you have the same basis, the exponents must equal to each other. We divide both sides by 2, I'm sorry. So x equals to 3 over 2. And again, you can always check your work to see if you're in the right track. Okay? So let me go here, so check my work. Let's see here. So I'm going to plug in 3/2 for the x. Okay, now, a quick way to do this one, guys, is like this. The 2 is my index, right? My 2 is my index. What's the square root of 9? It's going to be 3. And this is the power. What's 3 cubed is 27. You can do it that way too. And again, this is my index, right? So that means the square root of 9. The square root of 9 is 3, and this is this raised to the power of 3, which is 3 raised to the 3rd power, will give me 27. Okay. Now let's do another example here. So let's see here again. So here, these are not the same basis. So then, does 4 to the something power gives me 32? No, so 4 to the 2nd power is 16. Let's try 4 to the 3rd power gives me 64, right? So it doesn't give me 32. That means we have to find the common basis between 4 and 32. Okay? 4 equals 2 squared, and 32 equals 2 to the 5th power. So again, I'm going to replace the 4 with 2 squared, and then bring down the exponent x minus 1. And the 32 will be 2 to the 5th power. Okay. Now here we're going to apply the distributive property again. So this is going to give us, right? This is crucial here, guys, because a lot of students make the mistake that they just multiply 2 times x and then minus 1. This is wrong. You have to bring this rule down, right? So it's going to be 2 times the whole exponent, which was x minus 1. You see, guys, now here we have the same base, which is a 2. Then we apply the rule. So the exponents must equal to each other. Now here we're going to distribute. 2 times x will be 2x. and 2 times -1 will give us -2 equals 5. So now we're solving a simple one variable equation. We're going to add 2 to both sides. So if we add 2 to both sides, right, it'll eliminate the 2 on the left side, and 5 plus 2 is 7. Then we divide both sides by 2. X equals 7 over 2. And again, we can always check our work. So my x is 7 over 2. So that's my x. So 7 halves minus 1 should give us 5 over 2, right? Because 1, right? So we get the LCD is 2, right? So 7 over 2 minus 1 will be the same thing as 2 over 2. So 7 minus 2 is 5, and then we keep the denominator, which is 5 halves. And again, here's how you can do this one without applying the rule, without the calculator. This is your index, guys. This means this is a root. So what's the square root of 4 is 2. 2 to the 5th power gives you 32. Or again, you can just put it in the calculator to get your answer. Now, we're going to be solving logarithmic equations. To solve logarithmic and exponential equations, you need to know previous properties, such as, these are properties from the past that you should know by now. I think you covered them a section earlier than this one. This one here means log of base a to the x times y equals log of base a of x plus log base a of y. Again, this is called condensed or single. This is called expanded. I believe in this course here, they call it single log, and this is called it expanded. I believe in the other courses, this is called condensed, and this is called expanded. So this is called the product rule. This is called the quotient rule. This is called the power rule. Okay, there you go. And they also work also for the ln. You see some property. If you have the ln, which is a natural log of x times y, right? We separate them or by putting the ln of x plus ln of y. And for the quotient, ln of x divided by y equals to ln of x minus ln of y. And this is called the power property, right? If you have the ln of x to the power of r, the exponent comes to the front, which is r ln of x. And similar with the logarithms. With the logarithms. So recall example number 7, right? You can always use log or natural log, the formulas here, or the properties to solve any problem without actually knowing the basis. This is like an alternative. That's why, if you recall this example 7, I believe it was right when you had to make the common base, which was 3. You can solve it another way. Remember, the answer was 3 over 2. So by using the power property of, I like to use the natural logarithmic instead of the logs, because when you get to the next chapter, which is the finance chapter, you don't use a log anymore. You use the natural log. That's why I like to keep it. I like to use the natural log, because that will prepare you for chapter 5. Okay, now, so how do we use it? We're going to apply the power property. We want the x, right, to come down. So we're going to use the power property, right, because when you have the ln on both sides, the exponent, like the r here, comes down or goes to the front. We done the exponent by taking the ln on both sides. Right, we take the ln on both sides. So by using the power property, the x goes to the front. The exponent goes to the front. Okay, now, right, so it'll be x ln of 9 equals to ln of 27. Now we divide both sides by the ln of 9. Hey guys, please be careful here, guys. The ln of 9 is a number. You cannot separate it. It's together. Same thing with the ln of 27. You cannot, they're together. It's a number. So you divide both sides by the ln of 9, and you get the ln of 27 divided by the ln of 9. Then you can use your calculator. So the answer is 1.5 or 3 over 2. Okay. And again, you can always check your work, right? But we did it last time, right? We checked it for this particular problem here. Okay, now, what I mentioned earlier, that's why I put it like in red and with all the explanation points. The ln of a number is an actual value. You cannot separate them. You cannot. Okay, so it's crucial there. Now comes another property. This is solving exponential equations with different bases. Okay. And again, we're going to be using the right. So we take the ln and the r goes to the front. This is the rule that we're going to be using. For example, this one here, you cannot find the same base. So I believe the steps to solve exponential equations is to first try to find the same base, right? To use the same base property. But then the second choice is to, if you cannot do that, then you're going to use the ln or the log. Okay. So not the same base, cannot get them with the same base, right? So bring down the exponent by taking the ln on both sides. And it's always right to the left of the number, right? It's to the left here and also to the left here. So by the rule, right, by using the power rule, the exponent goes to the front, the x goes to the front. Then we divide both sides by the ln of 5. So ln of 8 divided by ln of 5. Here we have to use a calculator. We just have to. And most of the times, it's going to say to round off to 4 places or 3 places. So it depends on what your instructor or what the platform that you're using. And most of the times is my math lab for this course here. They're going to tell you to round off to a certain decimal point. So here, guys, these lines here, or like the squiggly lines, means approximation. That's why this is not the exact value. The exact value is over here, which is ln of 8 divided by ln of 5. This will always be a decimal that goes on forever and ever, right? So that's why you put the squiggly lines, means it's being approximated to 4 decimal places. And again, you can always check your answer. Your answer, once you round off here, is not going to be the exact answer, but it's going to be real close to the answer. I'm going to plug in 1.2920 into the x, and it's going to give me something like 7.9996, right? If you round this off, it's going to round off to 8. Solving it, let's continue, okay? So now, this is similar to having the same base. Now here, we have the logs with the same base, right? If you have the logs, but let me read the rule here. It says let u, v, and a be positive real numbers, and a cannot be 1, which means a, u, and v are real numbers, are positive real numbers. If the log of base a of u equals to a log of base a of v, then u must equal to v. Example, we have the log, hey guys, if there's no base, right, we know it's base 10, right? I explained that last week. So the no bases mean base 10, right? So log base 10 of x equals to log base 10 of x plus 3 minus log base 10 of x minus 1. This example is the first example that they give you in the book. They don't give you nothing easy for this section here. They start you off with something a little bit more challenging. So for example, before you apply this rule here, right? Both sides of the equation must be single logs, right? The left side is a single log, but not the right side. And one more thing that I have to tell you, that the logs cannot be negative. Okay, so if you have log, say you plug in the calculator, log to a -3, it's going to give you error. And then also if you put log of 0, it's going to give you error, which means that the log must be more than 0. Okay, so for example, if one of the answers is 0, it means it's not a solution. Okay, so but I'll show you right there when we get there. I'll show you what I'm talking about. So first here we have to use the properties from before, which is right. So we have to go from expand it to condense it. If you recall, if we have a minus, right, it's going to be division. Right, to apply the rule, single log must be on both sides. Use the quotient property on the right side. So here, guys, when we have a minus, it's going to be the quotient property, right? Which means, right, so, and again, this was a single log, this is expanded, so this is the expanded, this is a single form of the expanded form, which is on the right side. Now, right now, we have the same log to the same base, so the u must equal v, right? So the x must equal to x plus 3 divided by x minus 1. We apply the rule. Now here, you can do it two ways. You can cross multiply, or you multiply both sides by the denominator of x minus 1. I believe here I'm going to use cross multiplication. This is the same thing as x divided by 1, correct? So I'm going to multiply x times x minus 1, and then 1 times x plus 3. You see? X times x minus 1, and 1 times x plus 3 will just give us x plus 3. Now here, we have to use the distributive property here. X times x is x squared. X times negative 1 is negative x, and equals to x plus 3. Now, every time that you have some form of quadratic equation, right? This is quadratic now because we have x to the second power. So that means that more likely you're going to have to factor. Okay, so you have to let this equation equal to 0. How do we do that? We're going to send x plus 3 to the left side. Okay, say the equation equal to 0 because it's a quadratic. So I'm going to subtract x to both sides and subtract 3, everything in one step, right? So the right side is going to be 0. But the left side, we have x squared stays how it is because there's no term or like term as x squared, so we bring it down. And these two are like terms, the negative x and negative x, so it'll be negative 2x. And the negative 3, we just bring it down. Now here we have to factor. And I believe in week 3, I did a workshop on factoring. So you can go back and review that workshop on how to factor. But factoring is crucial for the upper level math courses and also for the scores here. So to factor, right, it's going to give me x minus 3 and x plus 1. Yeah. So this quadratic equation is in factor form, which means now you're going to apply. This is called the zero property rule, but I believe it's not here. They don't call it the zero property rule. They just say to set each binomial equal to 0. So we have x minus 3 equals 0 or x plus 1 equals 0. So if we solve for x on the left side, it's going to give us what? It's going to give us 3, and here it's going to give us negative 1. Because if we add 3 to both sides, right, it's going to give me x equals 3. Here on the right side, if we have x plus 1 equals 0, if we subtract 1 to both sides, it's going to give me x equals negative 1. So these are my solutions. Okay, now, but remember that you have to go back and check, see if it's true. But right away, I know this is not the answer, the negative 1. Because if I plug in negative 1 to the log of x here, it's going to give me undefined, right? But let's find out. Here we go, check them. So when x equals negative 1, right? Because these were my two solutions, x equals 3 and x equals negative 1. If you plug in negative 1 for every x, you see it, this one's undefined, and also this one's undefined. Not defined, you see? And also this one over here. This will be okay, but if one is undefined, it means the whole problem, the whole value, the solution x equals to negative 1 is not defined. So negative 1 is not a solution. Now we do the same thing for 3, x equals 3. I'm going to plug in the 3 for every x, right? I'm going to plug it in there. I'm going to plug it in also here, and also here for this x here. So we have log of 3 equals to log of 6 minus log of 2. Now, this here, we can do it two ways, right? You can actually plug in the calculator, or we can apply the rule, right? We can apply the rule from before. This is like the quotient rule, or the quotient property, right? But like I said, you can use a calculator, but also, right, if you use a calculator, this will be the answer. But if you will use the quotient rule here, right? Or the quotient property is going to be log of 6 divided by 2, right? Because this is called the single form. This is called the expanded form. So 6 divided by 2 is 3, right? So we have log of 3 equals log of 3, which will be the same thing as 0.4771. Okay? And again, you can use your calculator, but it's always good to know how to do it by hand. So that's a solution. I believe, let's do one more here. Okay, now, hey guys, I think I'm going to finish early with this PowerPoint because I thought it had enough information, but we'll see what happens, okay? Maybe I can answer some questions after we're done here. Here, there's another rule here. If A and U are positive real numbers where they cannot equal to 1, then A raised to the power of log of base A of U equals to U. So in other words, when you have this is my base, right? When this base is equal to the base of the log, this cancels, this becomes 1. The U just comes down, so U equals U. So I'm going to be applying this rule here. Okay, let me show an example so you have a better idea of what I'm talking about. So for example here, right? We don't want this here. We don't want the log of base 3 there. So how can I get rid of it? By applying the rule here above. Need to cancel the log of base 3. So then here's what I'm going to do. Okay, it says that we let this expression here on both sides, this expression and this expression is going to be the exponent. And this base is going to be my base. You see, so this comes here. So what we do on one side, we do to the other side. You see now, this we can do this in math because in math, whatever you do to one side of the equal sign, you have to do to the other side. Now by applying the rule now, right? So this cancels here, right? This cancels, like for example, this cancels and the U comes down. So this cancels, this is equal to 1, and we bring down the 6x minus 2 equals to 3 squared. Now all we do is just basic algebra, right? Solving one variable equations. So we're going to add 2 to both sides. Right, so 9 plus 2 is 11. Then we divide by 6. This is equal to 11 over 6. Now we can check our solution. We can check our solution. Okay, so we're going to plug in 11 over 6 here for the x's. Right, so we plug it in there. So 6 times 11 over 6 right here, the 6 cancel, right? This is equal to 1 here. So we're going to have 11 minus 2. Okay. So then 11 minus 2 is equal to 9. So then here, remember guys how we read it last time? Or you can put it in the calculator. But this cannot be put in the calculator. You have to change the base. But how do you read this? This is how you get the answer. 3 raised to what power will give me 9? The answer is 2, right? This is how you read it like I mentioned last time. The base to what power will give me the 9 here. So 3 to the second power will give me 9. That's why my answer is 2. And I believe your instructor should already gone over how to change base, because log only the calculator, most calculators can only take base 10. If it's not base 10, you have to use the change of base. The change of base means your instructor should already had explained it to you. But if not, perhaps myself or some of the tutors can explain it to you right now, because I believe that's it with my PowerPoint. Hey guys, I apologize that I finished early, but at least we get to get some questions if you have any questions. Okay. Let me stop sharing.
Hi, can you hear me?
Have any questions for Mr. Azasi?
Yes. I was wondering if you recorded any previous videos. I would like to see them all as well, please.
Oh,
my email.
It's in the chat right now. There is previously recorded TVE sessions. There's a link to our YouTube playlist channel. It has all the ones from this semester so far, last semester, as well as even the spring semester. Are you able to access it?
Yes. It is the previously recorded TVE sessions, right?
Yes. Hmm.
Jennifer, can I ask you a question?
Yes, sir.
What are you taking right now? Are you taking 1324?
Yes.
If you want, you can join me for Sunday numbers. I do Sunday numbers every Sunday, and I can
Yes,
help you with the
I took a
material.
picture of it.
Yeah, I can help you with the material. If it's the upper level courses like 1324, I can help you with that. And if it's the O324, Mrs. Sassi can help you with that because she does the developmental courses, and I do the upper level courses. Welcome to join me every Sunday. I mean, I can help you with the material. But for 1324, it's from 9 to 10 because every hour I do a different course. So if you need help, join me 9 to 10 every Sunday. Okay?
Okay.
Thank you, my friend.
Thank you very much.
Are there any other questions for Mr. Azasi?
No, sir. No, ma'am.
Okay, thank you. So before we let you go, I would just like to invite you to next week. Here at Town of Virtual Events at 1 p.m., we're going to have presentations from Campus Life and SGA, as well as during Happy Math Hour, we'll be covering Math 1314. We're going to be going over finding zeros of polynomial functions. In Math 1324, we're going to go over simple and compound interest annuities. So we hope to see you there. Thank you all. Thank you, Mr. Azasi, for presenting today. Thank you, audience, for coming today, and I hope you have a wonderful weekend.
You too. Bye.